Alright, so this is book 4, proposition 10. Our givens is the line AB, and we're trying to prove an isosceles triangle that has this angle right here times 2 is equal to the angle here and the angle here. So the first thing we're going to do is use book 2, proposition 11, to make it so that, to get the point C. So we get that by AB times BC is equal to AC squared. And now that we have that, we're going to build a circle around the point A, the radius AB. And that we can do that due to definition 15. And now we're going to use book 4, proposition 1 to duplicate this line AC touching this right here. And so there, and that's book 4, proposition 1. Call that BD. And now we're going to connect the line AD, that's postulate 1. And that's our construction. Now we're going to prove it. So what we're going to do now is we're going to connect C and D due to postulate 1. And we're going to build a circle using book 4, proposition 5. And so, which allows us to build a circle using 3 points. That's okay. And so that's our circle. And now we can see that AB cuts through the circle ACD. And we see that BD touches the circle here. And because of this, we can use book 3, proposition 37, which allows us to say that this touches. Oh wait, we can use it due to this right here, and due to AC is equal to BD. AC is equal to BD, and therefore we can say that AB times BC is equal to BD squared. And so now we can use proposition 37, which means that we can dictate that BD is touching the circle ACD. And so, yeah. It touches the circle. And now that we have that, we can use book 3, proposition 32 to say that the angle here is equal to the angle here and here. Maybe. Okay. 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 So now we know that. Okay. Now that we've used book 3, proposition 32, we know that the angle BDC is equal to the angle CAD. So CAD is equal to BDC. And now that we've done this, we can use common notion 2 to add this angle CDA to both sides. So that would be CAD plus CDA equals, and due to common notion 4, the angle BDC plus CDA is equal to the angle BDA. So we can just put BDA. And now that we put that, we can say that, now we move on to the proving the next angle. So this is our equation that we'll be plugging into later. So the next part of this uses book 1 proposition 32, the exterior angle proposition, which says that this angle here is equal to this angle plus this angle. So angle BCD is equal to CDA plus CAD. And that's due to book 1 proposition 32. And now that we have that, we're going to use book 1 proposition 6 to, proposition 5. We're going to use book 1 proposition 5 to say that this triangle ABD is an isosceles. And we can do that because we know that AB and AD are radii of the same circle, and so that they're equal, and therefore this angle and this angle are equal. So that's angle CBD equals BDA. And now that we know this, we're able to do the exact same thing on this triangle right here. So we know that the angle BCD is equal to the angle CBD because we proved that earlier. And so CBD equals DCB because we proved that up there. And now we can use book 1 proposition 6 to say that CD equals DB. And now that we've done that, we can say that now that we've done that, we know that AC is equal to BD because we proved that earlier. And now that we know CD is equal to DB, we know that AC is also equal to CD. And so that means that these lines are all equal, which means that this angle and this angle are also equal. And because of that, we can say, due to our earlier thing, if CAD is equal to CDA, then this equation becomes 2CAD equals BDA. And because we know that the angle BDA is also equal to CBD, we can put that 2CAD is also equal to CBD. And that's what we were trying to prove. And so we put our QAF. So yeah, there you go.